Have you ever heard that hot water sometimes freezes faster than cold? Trust me, it sounds impossible, but this quirky phenomenon is real, and it's called the MPEMBA effect. Yeah, I know. Physics just loves to mess with our heads sometimes. Let's rewind a bit. The story starts with Aristotle way back in ancient Greece. He noticed this weird behavior, but everyone kind of forgot about it. Until 1963. That's when a Tanzanian student named MPEMBA was making ice cream in class. He put a hot mixture in the freezer, just like you're not supposed to do. And to everyone's shock, it froze faster than a cooler batch. His teacher thought he was crazy, but Aristo stuck to his claim. Eventually, scientists took notice, and the effect was named after him. So why does this happen? Well, scientists are still debating the exact cause. There's no single answer, but there are some pretty cool explanations floating around. Let's break them down. First up, evaporation. Hot water gives off more steam, so it actually loses mass as it cools. Less water means there's less to freeze, and sometimes that alone gives hot water the upper hand. Next, convection currents. Hot water stirs itself up more as it cools, thanks to those wild temperature differences. This mixes things around, spreading the heat evenly and sometimes speeding up the freezing process. Here's another twist, the temperature of the surroundings. If you put a super hot container on an icy surface, it might actually melt the surface underneath, making better contact and pulling heat out faster. Basically, hot water can hack the environment to its advantage. Don't forget about dissolved gases. Water straight from the tap is loaded with oxygen and other gases. Boil it, and a lot of those gases escape. Fewer gases can change how ice crystals form, which sometimes speeds up freezing. And then there's supercooling. Cold water can sometimes drop below 0 degrees Celsius, without actually freezing. It just sits there, colder and colder, until something triggers it to freeze all at once. Hot water, on the other hand, is less likely to supercool, so it might freeze solid while the colder water is still waiting around. Bottom line, the MPEMBA effect is like a riddle wrapped in a mystery, dipped in science. Even today, no one's cracked exactly why it happens every time. But it's a reminder that science isn't just about knowing all the answers. It's about asking wild questions and daring to challenge what you thought you knew. So next time you're making ice cubes, think about Aristo MPEMBA. And remember, in science, sometimes the weirdest results turn out to be true.